Hey folks, I've been working on the analog ROM system a bit. I've created kind of a disgusting behemoth that I'm going to try to walk through here. Um, so this is a 7-segment decoder using all this analog stuff I've been building. So you can see right now it has a 0 displayed. Can turn on the 2's lever, and eventually it'll turn into a 2. Takes a second. So there's like a 2. There's a 3 eventually. It's kind of slow. 4. And so on. It doesn't really... I don't know. I'll talk about what each digit looks like later, I guess. I've covered every component that's used in here in its own video, so I'm not going to talk too much about like how the redstone specifically works. I'm going to kind of talk in higher level terms about just memory in general. But just to give a quick overview of this system, I have my 4-bit console here. That goes to the 4-bit analog encoder. Oh, and I'll post links to the videos where I talk about each of these components in the description, in case this is the first one you're seeing. Anyway, so the analog encoder goes to this spot here and here, at which point the input is sent to the address buses of each of these ROM sections here. And each of the ROM cells is part of the output that writes the number to the display here. Each of the ROMs is synced up to the same address, of course, so they both output the same corresponding nibbles to their output buses. The output goes through one of these analog to digital decoders that I've talked about previously, and then the outputs from there are attached to the different sections of the display here. So let's see, what is there to talk about here? I guess the main mechanic that's worth talking about here is attaching these two ROMs together. So basically, this display requires a full byte, or it requires 7 bits, 1 for each section of the display. So a single one of these things that only can put out 4 bits isn't enough. So either I'd have to rebuild this to have an extra output line itself, or build a second one of these, which I did. So each of these outputs part of the code that goes to the display. So this ROM in blue outputs the byte, or the nibble rather, that controls this segment, this segment, this segment, and this segment. And in orange, the lower ROM outputs the part of the code that turns on and off this segment, and this segment. So together they can draw the complete picture. The busing for this is kind of a mess. I went with kind of a weird curved design for the decoder, which I've talked about the pitfalls of this in another video. But it makes busing kind of a mess with everything kind of coming from all directions. I was able to get it to work, but it's ugly as hell, basically. Anyway. Oh, so I should talk about how the codes are established. So basically, this is the 8's bit of the blue ROM. This is the 4's bit, this is the 2's bit, and this is the 1's bit of the blue ROM. So basically, I just put in a number into one of the chests for given a value that draws this picture for that part of the ROM. And I do the same thing with the other one. So for this one, in the blue ROM, the 8's bit is 0, the 4's bit is 1, the 2's bit is 1, and the 1's bit is 0. And then the other one, I forget which segment corresponds to which bit, but it's the same deal. So I can show off what each number looks like here. So here's 0, here's 1, this is going to be 2, 3, 4, 5, 6, 7, 8, 9. And at this point, we're going to hexadecimal digits. So 10 is represented by, 10 is represented by A. 11 is B. That's going to be a lowercase b. 12 is C. 13 is D. It's a lowercase d. 14 is E. And 15 is F. So yeah, that's my 7-segment decoder. I know there are, I think Mobo Jumbo made a 7-segment display that's like way more compact than this. It's just hooked up to a counter. That's probably the solution you should go for if you just want to count like, a timer or something like that, if you want to do a clock or something. But if you want to just write arbitrary digits in arbitrary order to a display, this is kind of the sort of system you would be looking for. I'm not sure if analog is the correct method to do this with, honestly. It's what I chose to do it with, but I think binary would probably be a lot faster, for one thing. But anyway, if you need to write like random numbers to a display, you'd use something like this, where you'd have your input set up to either a pair of 4-bit ROMs that look like this, or just an 8-bit ROM, and or rather like either a 16 by 8 ROM or two 16 by 4 ROMs like I have here. And then the outputs for both data lines would go to your display. But anyway, yeah, that's my 7-segment display with decoder.